Okay, I think we can start right now.
Okay, do you want to go ahead and do the first part?
Well, yeah,
I can
perfectly.
switch the slide for you. Yeah.
Okay, great. That would be great. Yeah, just to let you know, everyone, and also first of all, welcome to our General Assembly, and we are slightly over the time, just 4 minutes, but welcome everyone. Good afternoon, and good evening, and good morning, wherever you are. Just for your information, this meeting will be recorded, and it will be on our social media platform after a couple of days to weeks, hopefully. So please let us know if your name or your face you don't like to be visible on social media platforms and publicly. So please let us know beforehand, so we will try to blur that on that part. So, okay, let's begin our General Assembly. First of all, here, me and Pond, we are the co-lead of this group. We will give you the more introductions of this group eventually. And the best part is that we have two guest speakers from DLR and from EUSPA, Miss Cécile. Sorry, please let me know if I pronounce your name perfectly. I'm sorry if I did not, but please let us know. And Stefan from EUSPA. And also we have some member speaker. One will be the Pond, which is one of the co-lead, and also there will be one Sagarika. She will be presenting one of the topic. Next slide. So the agenda is that we have, as I said, that we'll give this a little bit update. Then we have the speakers from EUSPA and DLR. Then we'll be talk about our projects a bit, and then what we have done, and also that what we are planning to do, which is a bit of with Earth observation sectors, and also we are planning to doing on the GNSS part. And then eventually, if you have questions and anything, if you want to ask, we'll have discussion forum. We'll have breakout session, so you can ask. You can directly. We can discuss with each other face to face. I mean, definitely on online, but yeah. Next please. So yeah, so we are a group. Our group is within the Space Generation Advisory Council. We are in support of United Nations Space Applications, and we do a lot of work in the non-profit organizations. And we have, as you can see, more than 21,000 members globally, and we are spread around quite a lot of country, almost more than 80-90% of the world. And then we do lots of SGS events for who like space, who want to work on the space. And also, as our group is focused on the space technology for Earth applications, but there are other groups which are focused on the many different domain and sectors inside the space. So this is our group. And what we do, we focus on multiple UN goals, which are SDGs, the Sustainable Development Goals. Our aim is to improve the culture of the research and also collaborations, building network, who like and who interested in within the space technologies and all, and who would like to work with space data, with the Earth observation, GNSS, and all related applications. Then also, our goal is not only about the working, but also sharing knowledge as much as we can, and also giving training the people who are very early stage, but they have a passion to work on this sector. So we also support all these. So let's say that if you have projects and you say that, no, I don't know anyone, but I have idea, we support you develop that projects also, because we have multiple partners. So we also support them academically and also from the working standpoint, from professionally, and also from the industrial point of view as well. Next slide. So as I said that, so our goal is the building a capacity building, because we saw that there are also some skill gap because most of the cases, what happens is that whatever they teach inside the education sectors may not be beneficial when you come to the work, or even if you would like to have more extracurricular activities and also more understanding on particular research. So this group is for all different kind of people. So not only for people who knows everything, but also for people that who are coming to this field. So definitely our goal is also for the contributions to the high quality journal papers, conference. Later you will see that where we have presented so far and also how we are improving over a couple of years. Next slide. So we have around 400 members. We are constantly growing and we are a pretty new group, and we just started from 2020. So we are still growing, and we also have many diversified people from around more than 70 plus countries, and we have people from all over Asia, Europe, and also from the America. Next slide. So yeah, as I say that, you can see that there are many different people from around the world. We are still missing a couple of countries, but I believe many people can come and join, and also will enhance their knowledge and also skills and all. So yeah, this is the kind of stuff. I think from now on, Pond will take you on the road of how we are doing different projects and different achievements. Yeah, Pond, now it's stage is yours. Thank you.
All right. Thank you very much, Jyoti. So here's a list of a couple of projects that we have been doing. So there's the past projects that we have been doing. So there's things like trying to integrating social media data with remote sensing to study different type of disasters, such as the Bobcat fire and the Hurricane Ida, for example. There's also more outreach like projects, for example, GGO for schools, where we actually develop curriculum related to earth science for middle school students. There's also a more startup-like project, which is, for example, the artificial intelligence for ocean farming. This group has been presented a couple of times at the IAC, International Astronautical Congress. And that's a project that explore diversity in space industry, as well as how space-related NGOs responds to disaster management, for example. Now, we have two ongoing projects. So one of them is one of our flagship project that is started since 2020. So this is the real-time flood risk assessment in developing countries, mainly focusing on Cameroon. And we are using social media, optical satellite images, and also synthetic aperture radar to try to integrating the data together to create a flood risk map and trying to understand better flood risk associated in those countries. This particular project is also endorsed by UNESCO IGCP program for a couple of years now. And it's still ongoing pretty well. So we'll have a little bit more in-depth update presentation on this particular project toward the end of our General Assembly today. Also, second, we're also excited to introduce a new project on human impact research, and you will also hear more about this new project at the end of the General Assembly as well. So stay until the end if you are interested. And of course, besides this project, if you have new ideas that you would like to try, definitely feel free to reach out to us. And any one of you, if you have good ideas, I will help you start up the project and make your idea into get your idea into motion. Another thing that I want to highlight is that since this is the first General Assembly this year, I want to wrap up a couple of our achievements that we did as a group for STEA in 2022. Sorry, the title is wrong. So wrapping up the last year. So one of the project on the flood risk assessment in Cameroon, which is one of our flagship project, generally organized an annual workshop. In 2022, we also organized one on the theme of small satellites, constellation, artificial intelligence, and Internet of Things. And in this particular workshop, we got over 400 registered participants. About 70 end up joining. and it is mostly people based on Cameroon. And this is a good opportunity because instead of just doing the science, this is where we invite local stakeholders, so people from the governmental agencies in Cameroon who will make decisions about flood management. Also, local UNESCO office to come and join us as well. So this is when the scientists and the policymakers interact, and it allows us to help guiding what we want to do with the projects. If you're interested in those, we actually have a recording of the 2021 workshop up on YouTube, and the link is actually posted on our website. I'll let you know a little bit further down how to find them. Then the second achievement that we have is we have 2 different presentations at the 73rd International Astronautical Congress in Paris. So one presentation is by Jyoti on the actually both presentations are by Jyoti actually. So it's one of them is on the using remote sensing data to look at flood risk in Cameroon, and then another one is on Hurricane Ida. Now, we also published 2 new articles on spacewatch.global, and we can share with you the article as well. So the article introduces you to the type of work that we do in the project. One more overview type of things, and one more in-depth presentation articles. And then finally, we are also invited to present our work at the Scientific and Technical Subcommittee of the United Nations Committee on the Peaceful Uses of Outer Space. So this is also an event that organized annually as well. And SGAC always invite the project groups to actually represent SGAC at these events. Now, a little update on the STEA social media accounts. In case you didn't know, we now have Facebook, Twitter, and Instagram set up. So this was for a while now. And if you haven't followed us yet, feel free to do so. So you can look up SGAC_STEA for Twitter and Instagram, and SGAC.STEA for Facebook. Now, we also have released quite a big update on STEA website, particular on the events tab. So here we add a list of past events that if you want to learn more about what STEA is about, what we have done in the past, here's a good website. Here's a good point to start. So we have the detail of all the past General Assembly meetings, which we tend to do roughly 3 to 4 times a year. We also have details about the workshop from the Refra Source project that I mentioned. And finally, occasionally we also host tutorials for the group members, such as things like Introduction to Python, Introduction to GIS, or synthetic aperture radar processing, for example. So we'll try to update the resources on here as well. So for example, now for the Python, we actually have a Jupyter notebook that we developed for that tutorial available on GitHub, if any one of you are interested in learning more. Also, finally, I want to also congratulate 2 of our members. Actually, we picked 2 of our members to be the member of the year and social media. Definitely well deserved this award. Abhinash, if you're around, do you want to say a couple of words? I think I saw that that you are on the call.
Hello, am I audible?
Yep.
Yes.
Thank you so much for this appreciation. I'm overwhelmed, and thank you for supporting me throughout the year, especially our both co-leads, Pond and Jyoti, and also Charles, Sukuma, Dr. Desire, who have helped me to work harder day by day and taught me a lot of new things. And this has also inspired me to work even harder and contribute my best in the coming years. That's all for now. Thank you.
Yeah, thank you so much, Abhinash, for all your work that you have done for us. The second person that we like to acknowledge a big contribution to STEA is Chukuma Okoli. He's one of the project leader in our Refrasos project, leading a lot of efforts in the research side in terms of analyzing the remote sensing data. And that allow us to show our great work to many of the presentations that we got invited. So definitely congratulations, Shukuma, as well. I also see that you are around. Do you want to also say a couple of words, Shukuma?
Yeah, thank you, Pond. Thank you to STEA and our team members and those in referral, and Pond and Jyoti and all our leaders and hardworking members. It's been great working with you all so far, and I look forward to greater things happening this year. Thank you.
Yeah, thank you very much, Shukuma. So, so since both of them are on the call today during the breakout room discussion at the end, you are feel free to find them and discuss with them as well about what they have done. And if you want to get involved like them, what sort of work you would be doing. So finally, so now we have two colleagues here. So we already introduced ourselves. Here, each colleague position lasts for about 2 years. And then now my term is actually about to end really soon. So I have started leading the group since 2021. And now it's 2023. So it's time for us to actually open the call for a new colleague that will replace my position. I'll still be around to help STEA with and help the new co-lead with transitioning into the new role, of course. And I've been involved for STEA for a very long time, so I actually will still be around. And Jyoti will also be around to help as well. And to apply for this position, you can look at the applications that are available throughout on the SGAC website. And a couple of benefits that you can get from being a co-lead here. First is that, as you already see from our presentation, that you have an opportunity to attend international conferences, as well as also to get invited to speak at a couple of events, for example, at the UN Corpus meeting, for example. We'll also have a chance to interact with the senior level space sector leaders through SGAC events as well. And working with space policy experts. So you have about 10 more days to write the application. And if you have any questions, definitely reach out to me or Jyoti for more information. And I really encourage everyone actually that would like to be involved a little more to actually join and apply. It is a really good opportunity for you to develop your management skills. Even if you don't have management experience, this is where you can get the skills. As long as you are willing to invest the time to the position, we will be able to help you transition to the new roles. So for rough idea in terms of time commitment, it takes about 5 to 6 hours a week roughly, but also it's a bit depending on whether we have an event here and there or not. So it's not too consistent sometimes. So for example, if it's close to an event that we are organizing, then of course you would need a little bit more commitment. But on the average week, probably about 5 to 6 hours for this position. And yeah, so that's all the presentation that I have. And then I think it's time to move on to our guest speakers. Oh, actually, before that, maybe we open the floor for like a couple of minutes and see whether anyone has a question. Feel free to raise your hand or just unmute yourself.
Yes, if you have any kind of questions, you can literally ask now about our group and all.
Okay, I guess looks like no question for now. Feel free to ask them later at the end during the breakout session. That's the time when you get to know us. So please definitely stick around. And now I guess Jyoti can take the floor.
Okay, yes, thank you, Pon. Thank you for the great presentation. Now we will have our guest speaker, Stefan.
Hello, everyone.
Yes, perfect.
Okay, so yeah.
Yes, the floor is yours.
Thank you. Yeah, thank you most of all for having me and inviting me to this meeting this afternoon. I'm very happy to represent EUSPA, the European Union Agency for the Space Program, this afternoon. And I also have prepared a little presentation, and I will try to share my screen for my presentation. Give me just 1 second, and then I hope you are able to see it. 1 second, because I don't see my presentation here. Give me 1 second.
I think while you are getting ready, I think I can give you a small introductions about you to the people who are here. So about EUSPA and what EUSPA does and all. So EUSPA ensures that the Europe meets its GNSS objectives and that the public benefits from European GNSS, which is EGNOS and Galileo. It also supports on the development of applications based on Galileo, EGNOS, and Copernicus, and coordinates user-related aspects of GovSatcom in support of key EU policy goals. And they're starting the Cassini. So Cassini is therefore the European Union's initiative supports entrepreneurs, startups, SMEs in the space industry, including new space during 2021 to 2027. So yes, Stefan, if you're ready, we can see your screen now, please.
Okay, thank you very much for the introduction. Do you see my full screen now? Yes.
We can see your full screen, but I think you need to do on the presentation mode.
Okay, because I thought like on my computer it's in presentation mode, but you don't see it in presentation mode, right?
Yeah, I think you are sharing a different screen, maybe.
Okay, let me just check. Give me 1 second. Do you see the presentation mode now?
Not yet.
No, yeah, okay. So let me just check why it is not working. 1 second, I will try again. Okay. So it's working now? No, not really.
No, not really.
Okay.
I think you
then
can share the whole screen, maybe.
Yes, I can try. Wait. 1 second. I will try to do that. Okay. So, is it working now?
Yes, perfect.
Okay, perfect, cool. So yeah, hello everyone, and hello to this presentation for EUSPA, the European Union Agency for the Space Program. I will first of all go a little bit into details what we are and what we are doing, and then I will give you an insight of all the programs that we have, so that you may have a better insight of all the activities which is done by EUSPA. EUSPA is the European Union Agency for the Space Program, and we are actually a undertaking which was founded in 2002, which was related to Galileo. Later on in 2004, we have become the European GNSS Supervisory Authority. Later on, this has become the GSA, the European GNSS Agency, where we also deployed then Galileo and EGNOS, and later on, like 2 years ago, in 2021, we became the EU Agency for the Space Program, which is dealing now with Galileo, EGNOS, Copernicus, the Earth Observation Program, GovSatcom, which is satellite-based communication. And in the future, that is missing here, and you may have heard that as well, we will also deploy IRIS² at the EUSPA. We are based on a new space regulation from the European Union. So we are a body of the European Union, and we belong to the Director General of Defense and Space. And this has been set into stone also 2 years ago in 2021. This also means a new EU space program starting from 21 until 27 with a new regulation where space data and services are at the heart of technical revolution. And here you can see all the services that we are actually providing at the moment, starting with EGNOS. I think most of you know, but for all that doesn't know yet, it's a navigation signal to make it more accurate and trustable for safe critical applications, usually, of course, used in Europe and now operational in more than 400 airports in Europe. Then, of course, our flagship service, Galileo, Global Satellite Navigation and Positioning System. We have already reached more than 3 billion Galileo receivers worldwide. Then, of course, also our Earth observation program with Copernicus based on satellite and non-space data. We are the #1 world provider of space data and images with Copernicus. Then, as next, we are also having GovSatcom, secure satellite communication for EU governmental actors, especially important for rapid support over crisis areas. And we are also having the space situational awareness, the SSA, together with the SST, the space surveillance and tracking, space weather events, SWE, and NEO, near Earth objects. Also others, but I will go into detail later in that. But here also we have to add IRIS², a satellite-based internet provision, which has been decided last month in Brussels. What is the mission of EUSPA? Of course, it is exploitation. So it's the management, operation, maintenance, and the improvement, evolution, and also the protection of infrastructure. It is also the service provision of Galileo and EGNOS 24/7. It is also the GovSatcom hub, and it is also the front desk from this year on for SST, so for space surveillance and tracking. But it's overall also related to security accreditation for all components, operational security of Galileo and EGNOS, especially in times of crisis. We have seen a significant rise of spoofing attacks, and the operation of the Galileo Security Monitoring Center, the so-called GSMC. But also important for us is market development, communication, user uptake, applications, and innovation. Here you can see how we are spread over Europe. The headquarter of EUSPA is based in Prague in the Czech Republic, but we also have affiliates in Noordwijk in the Netherlands, in Saint-Germain-en-Laye, close to Paris, Toulouse, and 2 sites also in Spain, very close to Madrid. We have quite a budget, of course, for all these activities. And what is maybe most interesting here, we have more than 300 procurements, grants, and prizes that we can give out as an agency, which is very important for the European space ecosystem. Here you can see in detail the Galileo and EGNOS services that we are providing. Yeah, I will just go briefly over it. First of all, of course, the open service, that is freely accessible, a service for positioning and timing, which is accessible for everyone. The public regulated service is mostly a governmental service is encrypted service designed for greater robustness and higher availability for secure satellite communication. We have the search and rescue service, the so-called SAR. It locates people in distress and acknowledges that the distress signal has been received. We are also having the high accuracy service, the HAS, which delivers high accuracy services freely accessible, and which is under preparation and the moment is the commercial service authentication, the so-called CS. EGNOS, open service, same as Galileo here again, improving GNSS accuracy, intended mainly for high volume satellite navigation applications for use by consumers. We also have the safety of life services, SOL, providing a high level of integrity for users for whom safety is essential, and also the EDAS, the data access service, offering EGNOS data with a greater added value through internet, intended mainly for professional or commercial use. If we are going now to Copernicus, the Earth observation program from the European Union, we are looking at our planet and the environment to the benefit of all Europeans. The information itself is provided for free and it's openly accessible to users. And of course, you have a lot of areas where Copernicus can play a major role. If we are talking about the atmosphere, we are talking also about the air quality, atmospheric composition, ozone layer, ultraviolet radiation, emissions, surface fluxes, solar radiation, and climate forcing, but also in marine, in land, in climate change, security, also now especially with the conflict in Ukraine. It is a very important tool for the services working in defense and security, but also for emergency in terms of natural disasters, for example, where you can have an on-demand mapping for all the phases of the disaster management cycle, also early warning and monitoring service, and exposure mapping. Then when you're talking about governmental satellite communication, govs.com, you can see here also the new system which will be introduced soon, IRIS², which will be deployed in the near future for a more independent access for European independence. And we are also contributing as EUSPA to the EU agenda, which not only is about security and defense, like in IRIS², but it's also, of course, the Green Deal, climate protection, environmental protection, but also resilience in case of innovative downstream space sector. We are having a lot of instruments. I was already talking about it. We have like a research program which is called Horizon Europe, where we are trying to promote and support the European sector in terms of space data. So all downstream related research projects are handled within the agency, but we also have other projects like fundamental elements, where we supporting the development of receivers, chipsets, and antennas. And what is also very crucial for us is the Cassini program, where we have a seed and crowdfunding facility. We have Cassini hackathons, we have prizes, we have a business accelerator, and we also have designated matchmaking for space startups and SMEs to connect them with investors, venture capitals, and family offices from Europe. So the Cassini initiative is maybe the most important initiative that we have at the moment for the European space ecosystem. It is to boost the space entrepreneurship in Europe, tailored to the needs of Europe's new space industry. And why support space entrepreneurship? Of course, we want to support new products and services, so space technology for new functionality and lower cost, also for digital services based on space data, information and services, new business models, of course, because as we can see, we have sharp increase of money going into space businesses. So commercialization of space is a very important topic, but also we have new financing schemes where we have acknowledged the increasing role of venture capital funds, but also the debt funding access requires customers and revenue. And here we want to promote also those actors in the market in Europe. Here you can see again all the different actions we are having at the moment at EUSPA. Starting with matchmaking, where we try to match European startups with investors. Not only, we are also reaching out to corporates to enhance the industrial partnering. We also have like a Cassini Business Accelerator, but also investment, which we do together with our partners within the European Union, like InvestEU, but we also have like Cassini prizes, like my EU Space competition, and also the Cassini hackathons, where we are giving out mentoring for teams which are working with space data. And Cassini is actually a very important instrument for us because it supports entrepreneurship during the entire innovation cycle. So if you start with an idea with some kind of innovation, we have Cassini hackathons and the Cassini prizes, where we can support your startup already on a very early stage. And then if it goes on, we have the European Innovation Council, the EIC, together with Horizon Europe, where we can support research projects. And then for bigger companies, we have the Cassini Seed and Growth Funding Facility, and also the Cassini Matchmaking, where we try to match startups, SMEs, but also bigger companies with big corporates, investors, venture capitals, and family offices. If we are talking about the Cassini hackathons, for example, we are having those hackathons twice a year. We have just finished the 5th edition 2 weeks ago. We are always having those hackathons all over Europe. They are on site on 10 different locations, but also online. So you can take part within the European Union wherever you are. And so our events are hybrid, and the 3 finalists are getting a mentoring for 100 hours with experts from different angles, like business, but also how to process space data. And of course, our goal here is to foster the next generation of entrepreneurs and problem solvers, and we also would like to connect the industry with the EU space ecosystem. And the next hackathon we are going to have will be in November. The last one I just told you finished 2 weeks ago, and the last one was about defense and security. And so this one was the last one I was just talking about. And as you can see here, they were in Poland, Hungary, Sweden, Romania, Latvia, Italy, and so on. And in every hackathon, we have like 3 different challenges. And here were the challenges: enabling cross-terrain mobility, making the CS more secure, and protecting our critical infrastructure. Then we also have the Cassini prizes, but usually those are only open for SMEs then that can participate with the consortium. We also have another prize at the moment where the deadline is the 3rd of May, which is about maritime. This prize is for the best data-driven marine or maritime digital application. And the solution here would be for detection, monitoring, and the removal of microplastic. So littering is a very huge topic for the oceans worldwide, but not only for oceans, but also in river shores and coastal zones. And here we would like to support a idea, a prototype, a business model which is making use of Copernicus and or Galileo data in combination with other data sources. And the first 3 winners will receive 950,000 euros cash prize each. And this is another initiative we are having. It is called My EU Space Competition. It is designated for startups innovating on the use of EU space data. Here you can see that the last cycle is still open, which means if you have a product to scale up, then you can apply until the 25th of April. But I have to say, you or one of your team members have to be registered within the European Union. Otherwise, you cannot apply. We have here a prize pool of 1 million euros, and we have to give out 30 awards. Then the Cassini matchmaking, I was also talking about this. It's a step-by-step support to startups, scale-up companies and SMEs to improve their ability to attract venture capital funding and form industrial partnerships. We have those matchmakings several times per year. You can always check it out on our website and you can apply, and we will check your application and will invite you then for the next matchmaking. The next matchmaking is going to take place at the tech show in Stockholm. I think it's at the beginning of May. And yeah, with that, I would like to stop my presentation here. And thank you very much for your attention. And if you have any questions, please feel free to ask.
Yes, I can be the first one in the meantime for the question. So it seems like there's a lot of applications that are opening and going on, and you probably have a chance to review a lot of these applications, like proposals or things like that. So what make these things stands out? Do you have any advice on some of us who might want to apply? So what makes an application unique, I guess?
Well, for the moment, I would say that because we have seen a very steady growth of applications which were based on GNSS, but what we are seeing now is more and more a merge of applications which are taking not only GNSS into account, but also EO. And here, I think you still have a lot of possibilities to invent and to work on innovations which haven't been there before. Because if it's about image processing, GNSS of course is a very interesting factor. So what we are seeing at the moment is that more and more innovations coming through are taking not only GNSS signal but also EO data and combine them and try to make a new to set up new innovations and also making business models out of it. So we see a very strong way into this direction.
I see. Thank you very much.
You're welcome.
Yeah, I have a question.
Please.
Yeah, thank you very much, Mr. Stefan, for the wonderful presentation. So, these are nice tools, nice innovations being introduced from my own personal experience working with ESA data sets, something I've noticed is that there's a lot of difficulty that users, end users who are not very how do I put it? In terms of accessing some products, for example, let me give you a Sentinel. The accessibility is not always so easy for many users. For example, for example, let me give you an example. I was working with a Copernicus DM recently. That's a Copernicus Glow 30. That's the 30-meter DM, and just downloading the DM from Pandas, that's the Pandas catalog, was very, very Herculean. And there was this back and forth. I had to be sending emails to, I've forgotten, I had to be sending emails to ESA back and forth, you know, and then it was just very Herculean. And then when I was on the interface trying to download the DM, it wasn't, it was quite difficult, you know, and then contrast that with, you know, maybe the ethics, some of the data portals for USGS or maybe some other agencies where if I need to download Landsat imagery or some other data sets, I can go there and literally within seconds. I just need to do a user registration, activation. Literally within seconds, I'm downloading imagery, you know, as much as I want. So one of the issues I've noticed with ESA products is from my own personal experience, and not just from my personal experience, from also, you know, I've worked with other people too, you know, who have also had experience working with different data sets. And interestingly, I was writing a paper recently and I checked online and I saw that there's even a discussion about difficulties associated with accessing ESA products. One is the interfaces seem to require people with some level of specialist knowledge to be able to, you know, access and really download those products. That's one. Two is the data access protocols seem to be very, very Herculean. You know, it's more like instead of you do a registration, activation, get the link, activate an email, and you get quick access. There's this wait for people at the back end to approve your registration. That might take some days. And something I've noticed is that comparatively, I don't have statistics, but comparatively, as you have more and more innovations and products by ESA coming out, I noticed that a lot of end users tend to gravitate towards other data sets that have easier accessibility. You know, so that's something I've noticed. Because, for example, if I compare Sentinel-2 multispectral, which is still a bit more recent, you know, but offers a superior spatial resolution than Landsat, you know, I still see that despite a lot of those, or you talk about the Copernicus DM, which some studies have shown that the Copernicus DM is far has higher accuracy than some others, right? So it's what are you doing, or is there any move to resolve some of these data access issues that end users are facing, which are affecting the wide usability of many ESA products? Thank you.
Thank you.
Yeah. Sorry, I know it's a long question.
Yes. Okay. Because I think we are running out of time now. Because your statement was a bit longer. I just have to say that we are aware of the accessibility issue. We are working on it, and we are also working on trainings to facilitate those access in the future.
Thank you.
Okay, perfect. Thank you, Stefan, for your amazing presentations, and it was interesting to see that how many things are going on behalf of EUSPA. Thank you so much. We will move to our next presentation from our next guest speaker, Ms. Cécile Deprez. I'm sorry if I'm pronouncing your name wrong. Please
Cécile.
correct. Cécile. Yeah. Okay, perfect. Thank you. Thank you so much. The stage is yours. Before moving, small introductions about you. She is a young researcher in the field of satellite-based positioning. In 2015, she graduated in geomatics from the University of Liège in Belgium. After 4 years of research on multi-GNSS positioning, she joined in 2020 the German Aerospace Center, or DLR, to work on next generation GNSS. With her group, she is investigating the integration of new optical technologies on global positioning systems. In parallel, she also has a very active role in various networks of women in STEM and delivering regular lectures on sexism and microaggressions in STEM fields. Yes, stage is yours. Please go ahead. Thank you so much. Yes, please go ahead.
Can you see my presentation?
Yeah.
Okay, perfect. Thank you for the introduction. And for the invitation also. I work as a researcher for the German Aerospace Center, DLR. I work for the Institute of Communications and Navigation, and my research group focuses on the design and definition of next generation GNSS. So in this talk, I will present the research that we are doing at DLR. And because I know that we are today a diverse crowd, I will just start first with a brief reminder on the concept of GNSS, so Global Navigation Satellite System. So let's start with GNSS applications. They are used everywhere around us, and I assume that you're all very familiar with GNSS most common use for navigation purposes. So when you turn on your mobile phone to find a nearby restaurant or to navigate to a friend's house. Over the last decade, satellite navigation has also become essential in many areas, such as, for instance, agriculture, aviation, but also maritime and shipping fields. GNSS is also used by surveyors for mapping purposes, for space applications too, and also in public safety and disaster relief, like for instance, the search and rescue services from Galileo. So there are 4 global navigation satellite systems: GPS, the US Global Positioning System, which is the most famously known. The initial concept for GPS was developed by the US Navy in the 60s using Doppler measurements to compute positions. The GPS concept as we know it today was developed in the 90s in parallel to the development of the Russian system GLONASS. 2 additional systems were developed since then by China and by the European Union. So Baidu is the name of the Chinese system, whereas Galileo, we just saw it as the name of the European system. These 4 systems are independent, but they can also be used jointly for positioning purposes. And so typically on your smartphones now, you would always have a combination of satellites from these different constellations. It is worth noting that there are also some regional systems, like for instance, the Indian system, IRNSS, so Indian Regional Navigation Satellite System, and the Japanese regional system, QZSS, so Quasi-Zenith Satellite System, or also called Michibiki, which cover the Asia-Oceania region and is also compatible with GPS and brings a supplement of information for having a more precise and stable positioning over those areas. What are the main elements composing GNSS? So obviously the satellite and the constellation of satellites of a GNSS is referred to as the space segment, and it's typically composed of 30 space vehicles that are spread around a few orbital planes, as you can see on this figure, at an altitude located between 20,000 kilometers to 24,000 kilometers. These satellites have a lifetime of 12 to 15 years. They transmit radio frequencies towards the Earth, radio frequency signals, towards the Earth. And they all carry on board precise atomic clocks. And I will come back in just one slide to this notion of carrying precise clocks. Each GNSS is also composed of a ground segment, which consists for GPS and Galileo of a worldwide network of stations, and for Baidu and GLONASS of a regional network. So you can see here on this picture from EUSPA, actually, the Galileo ground segment. So you can see that the different stations have different purposes, but the main role of the ground segment is to track satellite signals, to monitor satellite status and satellite orbit. And some stations also can upload some information to the satellites. So a large network of ground stations is required to be able to track the satellites and communicate with them, but it's also expensive to maintain. And so we will see in the following slides how the next generation GNSS may help reducing the dependency on an extensive ground segment. So let's now summarize in 2 slides how satellite positioning works. I mentioned earlier the very precise clocks that are on board the satellites, and here comes the explanation on how to use them. So basically, satellite positioning relies on time measurement. So the time at which the satellite transmits radio frequency signals is flagged with a very precise timestamp from a very precise atomic clocks on board the satellites. The time is then compared to the time of reception of the signal at the receiver and multiplied by the speed of light. This allows to obtain the distance between the satellite and the receiver, according to the formula that you can see on the slide. To estimate the position of the user, typically X, Y, and Z, we have 3 unknowns. And so for this reason, we need to observe 3 satellites to solve this equation. However, an additional unknown needs to be considered: the delay between the receiver clock with respect to the GNSS reference time. This is this delta T that is written there. And for this reason, because we have now 4 unknowns to the system, we need 4 satellites to be able to do some satellite positioning. So typically, satellite positioning requires at least 4 satellites in view. So now that we've been quickly through the basic concept of what GNSS are and how satellite positioning works, let's get to the part of next generation GNSS. As I previously mentioned, satellites have a life expectancy ranging from 10 for the worst to 15 years. For instance, the first generations of GPS and GLONASS are, of course, not active anymore. So they have been replaced by new satellites that are incorporating new technologies. Baidu, the Chinese system, for instance, has already evolved through 3 generations of satellites coming from a regional system to a global system. And Galileo is going towards the 2nd generation in what we call G2G, Galileo 2nd generation, that is currently in preparation. So what are the kind of improvement that this new generation of satellite will bring with respect to previous one? So most of this new generation will bring new signals. Every time we try to have an improved accuracy, an improved robustness and strength and quality of the signals. Another feature also that will be brought by next generation satellites are improved satellite clock. We just saw before the importance of clocks. So this is always something that is improved generation to generation. Another technology that has appeared in the latest generation of satellites are the inter-satellite links. whether they are radio frequency links or optical links, so laser links. This concept was already thought, like in the 80s, was already conceptualized, but it's only now that some satellites come with those features implemented. But why would we consider links, satellite links, in the new generation? So there are actually three main features of these links that are interesting. The possibility of communicating between satellites, which so far was not possible. The inter-satellite ranging, so with those communication between satellite, we can also measure the distance between satellite, which can then be used in improving the orbit determination of satellite. And finally, time and frequency transfer. I've mentioned again before the importance of the satellite clocks, because this is thanks to a very precise timing that we can position the user correctly. So having time transfer between satellites also allows to potentially synchronize the entire constellation and therefore improve also the user positioning. So as a result, implementing those new features, and particularly the inter-satellite links, will allow, through synchronization of satellite clocks and the improved orbit determination thanks to inter-satellite links, to have also an improved real-time user positioning. And I mentioned those very extensive and expensive to maintain ground segment. The fact of having the possibility of communicating from satellite to satellite will also help reducing the dependency on the ground segment. So the four global constellations, GPS, GLONASS, BeiDou, and Galileo, are all either already implementing this feature or foreseeing it. So GPS-3, for instance, the latest generation of GPS satellites, implement new signals, new clocks, and also radio frequency link between the satellites. BeiDou 3 and GLONASS K, so the last generation for BeiDou and GLONASS, also have implemented inter-satellite links in order to compensate for their regional ground segment. And then G2G, so the evolution of Galileo, will also incorporate a radio frequency inter-satellite link. And there are several studies, and this is where DLR comes into play, where we actually also look into developing optical inter-satellite links. So here is the part about what we do at the German Aerospace Center. So mainly we worked on optical terminals and clock synchronization. So clock synchronization, actually we have a series of clock in our clock labs, and we test them. We try to we develop different in-house software and algorithm to be able to perform clock synchronization. Regarding the optical terminals, we also have had a series of tests to validate the technology that we are developing. So we are doing, so we had like a first laboratory demonstration of a 30-meter free space link in a controlled environment. And last year or 2 years ago, we had also free space link of 10 kilometers, which represent more or less the distance between LEO satellites, so low Earth orbit satellites, and the ground. So it was a test to see like how the optical links would perform in a free space environment. And so for each of this validation mission, we evaluate the time and frequency transfer capabilities of the links, as well as their ranging precision. We also have developed a system simulator. This is more the work we are doing in my research group. So the idea is to develop a system simulator in which we can simulate both the next generation GNSS, but also the current GNSS and their capabilities. We will simulate the orbits and the clocks on the satellites. So you can see on the top left picture, the Spirent simulator. It's a commercial tool. It's a very big one that allows to simulate these orbits and these clocks. We will also simulate the radio frequency signals that are transmitted by the satellites, but then also the inter-satellite links. So those optical inter-satellite links that we would like to incorporate in future generation of GNSS. We have to simulate them, so simulate the ranging that we will obtain between satellites, but also schedule them, because the constellation of satellites are constantly moving, evolving, and therefore the topology between the links also evolves. So we had to design some scheduler algorithm. We also work, as I said before, on the satellite clock synchronization, so trying to synchronize all the clocks through the links. And in the end, we compute positioning results for the user, trying to see if incorporating such optical intersatellite links would help also the user to get a more precise or faster positioning. We also have two very exciting in-space validation missions coming. We have the Compasso mission, which take place in 2025, in which a laser communication and a ranging terminal will be installed on the European Bartolomeo platform on the International Space Station, and where we will test optical links between the ISS and the ground, and we will test there the time transfer and the ranging capabilities. And the second in-space validation mission that we have is this ESA project, OPSTAR. So OPSTAR stands for Optical Synchronized Time and Ranging. It's a phase 0 study for a future in-orbit validation mission. It's a collaboration, DLR with TESAT, with OHB and SpaceOpera. And the idea there, so you can see on the left the picture, is to have 2 ground stations and 2 satellites, and to actually simultaneously observe the different links between those satellites and the ground station in order to validate the time synchronization, the ranging, and the data dissemination that we can have with these optical intersatellite links. So that's all for my presentation. If you have any question, please feel free to contact me either at my DLR email address or on LinkedIn using the QR code that is there.
Perfect. Thank you. Thank you so much for this presentation. It's definitely great to see that how GNSS has been changed our life over decades. So yeah, please, anyone, if you have any questions, please feel free to ask. This is the right time, I believe.
I guess I would like to go first on this one too, and that's because actually I'm one of the end user of GNSS actually, so maybe a little bit of background. So I use GPS measurements on the ground to actually measure the surface deformation on the Earth. So in particularly, we are looking at earthquakes and things like that. So basically positioning on the Earth is what we are caring about. And also we don't care so much about absolute position, it's more the relative position. So basically how much things are moving. And one of the challenges that we have is that with proper processing using typically final orbit solutions would require 2 weeks after the acquisition is done. With that, we can get this displacement measurements to about maybe 1 millimeter resolution. And now with the interlink connection and things that you mentioned, and also a possibility of doing a real-time or improved real-time processing, do you imagine that that 1 millimeter resolution can be possible to be done in real time, or do we still have to wait for final orbit solutions? Or I guess what sort of resolution do you think we can improve with this new generation GNSS?
And thank you for the question. Actually, this is exactly the advantage that we identify with using these optical intersatellite links, is that the orbits are greatly improved, as well as the satellite clocks, and therefore the products that we could put into the navigation signal that you receive in real time actually are just as good as the one that you would get in the final product from the IGS, allowing this improved real-time positioning for the user. What we noticed so far is more an improvement on the convergence time. So I guess you're using some precise point positioning solution there. And so we noticed with the first results that we have that we divided by 2 at least the time of convergence with those improved orbits and clocks. Yeah.
I see. Yeah, that's great to hear. What about the final orbit solution? Do you think we'll be able to improve that as well, or is it mostly the advantage is more on the real time?
I don't know yet how the final solution will be. I know that we've made, so we compute the CESRE, so the system in range error in space. And for this, we have like an improvement over the CESRE of the actual Galileo constellation. I think we go below the centimeter level so far. So we keep incorporating some biases and errors in our simulation that are quite clean at the moment, but they are very promising, but I cannot give you a number so far.
Okay, anyway, yeah, sounds good. Also, I guess I want to share a quick 1-minute thing of why I think this is important to me. I guess the ground start to move, the seismicity or earthquakes start to come up, and this is because the ground is moving, stress is changing, so it's changing the state of the stress of the crust, and usually these things will probably happen in order of a day or two before the earthquake sequence, for a particular earthquake sequence, of course. So we cannot predict earthquake, but we can have some forecasting power. Now with the final orbit solutions, if you have to wait for 2 weeks to be able to model this thing, then you cannot forecast earthquake in real time. But if we improve this real-time positioning system, where we might be able to forecast a particular earthquake sequence in real time, so that's really exciting. Yeah, okay, I'll let the other people ask questions as well.
Okay, I think we should move ahead with the next part of our. Yeah, sure.
That there is a request, and I can send the present. I don't know if you will send the presentation or if I should. I can transmit the presentation to you. There is someone asking for it.
Sure, definitely. And also, anyone, if you want the presentation, please reach out to us, and we will deliver the presentation.
Okay,
thank you so much.
I will send it to you afterwards. Thank you.
Sure, perfect. Thank you. Okay, so now we will move ahead with the presentations from our internal STEA projects. And the first one will be done by Pond. And this is a project that what we were referring slightly a couple of minutes back, which is the real-time flood risk assessment in developing countries using social media, optical, and satellite data. In short, REFRASOS, and this project is supported by UNESCO. Pond, the stage is yours. Please go ahead. Thank you.
All right, thank you very much, Jyoti. So I'll try to be a little brief so that we have some time for discussion in the end. So this is presentation made by Shukuma. So I'm mostly presenting on his behalf. And this is the same set of presentation that we deliver during one of the workshop that I mentioned. And the idea is to do it's kind of like a progress report thing, showing what we have done with the project. Okay, so I can skip this introduction. So the area that we're interested in is in Douala. So this is capital city of Cameroon. So it's a city in Central Africa. It's a coastal city, so with access to river and water. And that's why flooding is quite common here. And it's due to the precipitation and so on. So there's a lot of rivers and low-lying area, floodplains that occasionally flooded. So that's why we are interested in this problem and try to create a flood susceptibility. Well, the end goal would be to create a flood susceptibility map and try to understand better whether we can use data like Twitter data to help us understanding or mapping better the flooding conditions. We have actually a conference paper, so both for 2021 and 2022. And if you wish to, I think most of them are already on ResearchGates, but if you wish to get access to this, definitely feel free to let me know, and I can give you access to the article. Here's I guess a sentinel image coming from UN spider change detection approach for Douala before and after. So it's allow us using SAR, synthetic aperture radar, which is sensitive to the surface of water. We can use that to map the extent of the water and determine the flood location. So that's one way to do it. And here's some of the flood extent that we are delineated from the SAR images. Another thing that we use before we go into more remote sensing style, I want to review quickly about the Twitter part that we have been using. So we use a keyword, Cameroon flood or Cameroon inundation, which is in French for flood, and we see whether how many of the tweets are having this this keyword over the period of 2010 to about now, and we detect about 4,000 tweets in total. And interestingly, we can see that occasionally you see a pop-up of jump. So this is a cumulative number of events of cumulative number of tweets versus time. And typically people would tweet randomly, so you would expect that this number linearly slowly increasing in time. But occasionally, when you have flooding events, people are tweeting more about flooding events, and that's why you see a peak or a jump in the cumulative number of tweets. And actually, you see a rapid jump, and it slowly decay afterwards. So this is a really characteristics of what happened during the flood event. And by looking at just cumulative number of events alone, this can help us identify the flood events and where we should look in our SAR images to learn more about such particular event. Now, looking at such a tweet, we can also do some sort of sentimental analysis to see whether people positively writing something about the flood or negatively writing something about the flood. We can also look at whether the tweet is more subjective or more objective and things like that. So this is things that we can explore using the Twitter data. And even though what I would say is that comparing to other type of data, social media data is really rich. It means that we have so much data available out there. However, it is so hard and sometimes difficult to utilize it because the data is quite messy. So that's why we have interested in using this sort of data as well. And this can help us improve over the remote sensing data and help us interpret how, besides just whatever where the flood is, this will help us identify what is the damage that it does to the society, both from the physical point of view and also the emotional point of view as well. Okay, I can skip the highlights. Now, going to the remote sensing side, I want to show you also a little bit of the work that we have done. So we are using a simple logistic regression models. So first, in order to predict or make a forecast of the flood susceptibility spatially, we have to look at a couple of factors that could potentially introduce or involve or be related to a flood susceptibility. So these are things like water, I guess the depth of the sediments, the thickness of the bedrock, for example, the type of the surface that we're looking into, the elevation, the slope, the roughness of the terrain, and things like this are the factor that we can input into our model. Now, what we are trying to predict, since actually it is really hard to derive flood susceptibility model directly, we are actually using this particular one on the bottom left. Actually, this is the MNDWI, which is a particular index that are calculated that can be roughly used to estimate the flood susceptibility. So we are trying to use other indices that are not correlated with this. After we input this data set, we do registration, resampling, because another challenge is that each type of the data are not necessarily sampling at the same point or with the spatial sampling resolution. So we have to resample it and match them together. Then after that, we can do the logistic regression modeling and get the predicted flood susceptibility map. And we can compare and do the validation. So we can only use a couple, maybe 70% of the points to do the training or to do the fitting. The other 30%, we don't use those data in terms of fitting, but we try to see how good we are performing in those cases. And here's the results. Here's our flood susceptibility maps, and here's the curve that you typically produce. The true positive rate versus the false positive rate. So true positive rate is basically how much are we with the particular model, how many of these events are we predicting correctly. And false positive rate is basically so false positive rate is basically the point where the prediction is wrong, basically, in a sense. Yeah, and then besides that, you can also characterize the area and divide them up to see how much of the area in this watershed is actually having a low susceptibility level and where it is high. So there's most of the high flood susceptibility area is expected to be along mostly closer to the coast, closer to water bodies, as we're expecting to see in this map. And I guess I'll leave it out at this point. So basically, we use a couple of data sets to try to model the flood susceptibility map, and we identify that some region have low coverage, and then some about 10-20% has a high risk of floods. And yeah, so I will leave it at that point, just to not take too much time, and then I'll be happy to answer any questions that anyone might have.
Okay, perfect. I think, by the way, I actually put the link on the chat. So if anyone wants to, see, when to read about it, please go ahead, and it is open for everyone, even the paper as well. Perfect. If anybody has any question, you can ask right now, or you can also after the next presentations. So no problem on that.
Yes, one question here from Karen von Hühnerbein from Germany.
Okay.
Have you been able to validate this, and how many correct predictions have you had?
Yeah, so I think roughly 70-80% performance is the correct prediction that we do. But also it's a bit earlier. Well, I guess the project is still at quite an early stage at this point, because we're just using a simple logistic regression model. Basically, just multiply the numbers together with the different coefficient, and we can make this a little bit more complicated, more traditional machine learning point as well. And also another downside that we have to work out at some point is also the ground truth. We don't really have the ground truth of flood susceptibility, so that's why we're using one of these indices as the ground truth for now. But we'll be improving on it.
Thank you, and also thank you for sharing the research paper. That's great. I'll have a look.
Yeah, of course. And also, I guess this is also the time to advertise the project, that the project is still ongoing. And if anyone is interested in joining the project, feel free to email the email that I will be typing right now. And basically, it's open to all STEA members, even if you don't have experience with some of the analysis. This is where you can learn how you can use remote sensing data or social media data if you're interested in. I think we should move on to the
Perfect.
next
Yes.
presentation.
I think you can also put the email address on the chat. I think it will be easier, accessible for everyone then. Meanwhile, we will move to our next presentation. This presentation, it's quite interesting and it's quite new. It will be on human impact research, and it will be the building actionable policy work through satellite data and computation. But it will be presented by Sagarika. Rika, are you here?
Yes, hi.
Perfect.
Can you hear me?
Yes, we can loud and clear.
Okay.
You can start to share your presentation if you have. Meanwhile, I will give a small introduction about her. So Rika works with satellite imagery and data science during her internship at ISRO, RRSC. She worked on developing classification models. Oh, by the way, ISRO is the Indian Space Research Organizations. And she worked on developing classification models for satellite imagery and started to explore applications of Earth observation. She also founded Women of Aeronautics and Astronautics in India, if I'm right, through which She aims to bridge the gap between scientists, engineers, and students to create an inclusive space for all genders in space and space-related fields. Perfect, thank you. The stage is yours. Please go ahead.
Can you see my screen? The PPT
Yes.
is visible?
Perfect.
Okay. Thank you so much for the introduction. Hi, everybody. I'm Rika. So something that I'm very passionate about is using satellite imagery for human impact research, particularly looking at forced migration, human rights infringements, and as an extension to that, poverty and socioeconomic crises. So something that we're starting up right now within the group is human impact research. And the idea is for us to actually find the right data insights and the right data points in order for us to actually influence policy work and something that can be used on the ground. So we're just starting out, and it would be great if some of you could join us. So I'll just go through quickly what we're doing within the group or aiming to do and what this would encompass if anybody's interested. So for today, we'll be understanding what is human impact, what are the applications of satellite imagery within this domain, what are the benefits and the challenges that might arise, and what are the current topics that we are exploring. So human impact research is basically this amalgamation of using data sources. So we're using satellites and visual imagery, and then we're using computation and data analysis to process that. And we're trying to influence policy work. So it's encompassing all of these three things. And at the center of this is human impact research. The idea of human impact research is to look at sort of human interactions at a larger scale to be able to benefit society and human populations whilst we protect the environment, of course. And as you know, through other projects as well, the satellite data is very valuable. And now that we're moving into more hyperspectral imagery and spatial analysis, and if you've been in the satellite community, you know that there's a very interesting tool that's come out, which is called Segment Anything. And so all of these new and upcoming tools are extremely helpful for us to actually look into what is the extension of satellite data into human lives and how we can positively impact the population. So these are the three things that kind of come together. So in some ways, we're also trying to work backwards, because we're first looking at, okay, what are the things that we can actually impact? So what are the sustainable goals? What are the policies with poverty? What are the policies with human rights? And then can this data actually help that? So it's kind of a mix of all of these three things. When we look at the applications of satellite data for this, so we look at monitoring environmental changes such as deforestation, land use change, and climate change, but with respect to where human population is being affected. So there was a very interesting project where they looked at illegal deforestation and illegal mining to see and identify modern slavery and bonded labor. And so one of the ways is to monitor environmental variables to test this out. Of course, something that's very popular is, mapping urbanization patterns, which is also looking at sort of forced migration and things like that, and tracking population movements. And then looking at patterns for agricultural land use, crop productivity, impact of pollution, and other environmental factors on human health. So these are sort of the end products of what we're trying to do. Something that we've noticed, which is sort of the benefits, challenges, and methodologies in three separate ways. I won't go into this in detail. I'll send over the slides if you're interested. But what we've been seeing is that one of the biggest benefits is we get different data sets into what is happening currently. So when it comes to for example, human trafficking or human migration, all that we've been having are traditional sources, and the bias in those data sets is very, very large, because those are, influenced by socio-cultural backgrounds. Those are influenced sort of by geographies. They're influenced by a lot of things. And when it comes to satellite data, we see that we can reduce some of those biases and with what we're trying to do with HIR now is find the right way to actually use traditional data sources and satellite data together, have sort of like an adaptive mapping, if you can call it, and come through with better unbiased data points to actually solve these. When it comes to challenges, of course, data quality is something like open source data quality is something we do struggle with, but I believe with a lot of the newer constellations going up, that's something that will, will be able to overcome. The second thing, of course, is the complexity of data processing. How much do we bring in sort of traditional factors? How much do we process now with satellite imagery? And something that people are kind of playing around with now is semi-supervised learning models. So there's an interesting study where they try to do asset wealth management in some of the African regions using semi-supervised learning models. But of course, there's a lot of challenges there. So these are the three sort of pillars right now that we're working with. And the current methodologies that we have are still based on what we've been doing with climate and environmental variables. But I think when it comes to human impact research, that might change as in when we grow and make this project more viable. So yeah, those are the three pillars of what we're currently dealing with. The next thing is, what are the topics that we are exploring? So of course, human impact research is like sort of this umbrella term for multiple things. But the three main sort of subcategories that we're kind of looking at are modern slavery, human rights infringements, economic and social conditions. So like I mentioned, for modern slavery, it's using environmental variables to kind of detect illegal deforestation, mine monitoring. Something that we're seeing now is with the lithium ion mines, there are terrible working conditions. People are exposed to all kinds of diseases, and it's at sort of the bottom of the technology chain, and it's becoming really bad now. Something that we're also looking at is sort of sweatshop monitoring in Bangladesh, China, and South Asia and Southeast Asia in general. So there are a lot of these adaptations that, there's very few people thinking about, and something that we want to explore. The second would be human right infringement. So as you've seen with the Ukraine-Russia war right now, a lot of the war crimes in affected areas and mapping has been happening through satellite data. So within that, we kind of divide into two. One is politically driven geographies, and the other is economically driven geographies, and looking at how better human lives can be affected, and how can we actually help them and rebuild, and look at those patterns for that. And the third would be economic and social conditions. So assessing poverty, being able to predict what are the factors that could affect poverty, and looking, of course, at migration, and whether the migration is forced migration based on economic, political, or cultural reasons. And so, yeah, those are the three main topics that we're looking at. And yeah, if you have any questions, or if you would like to kind of join the group, we'd be more than excited and happy to have you on board. Thank you.
Thank you so much for your presentation. Yeah, if anyone has any kind of question, please go ahead and yeah.
Hello, good day to you all. I just want to ask, when she said that for those who want to join us, they are welcome. How can one join their research?
You can actually email to us that if you want to join a particular project. I'm writing this email ID on the chat box. This is called the STEA@spacegeneration.org. I just put it on the chat. So you can let us know that which project is most interested, or what you want to do. If you have any kind of new project, please write down to this email, and then we will put you in contact for a specific project leader.
Okay, thank you very much.
Perfect. You are welcome. Yeah. Does anyone has any kind of other question? Yeah, thank you, Karen. Okay. Then if you don't have any kind of questions, we will move to the main part of General Assembly is finishing here. The next part, it's more on if you want to discuss any particular topics, anything about STEA, about the co-lead positions, about doing the project, and everything. Please come and you can open your mic, open your video, or however you can ask us any kind of question. Yeah, thank you. Thank you for your presentation and all.
Thank you. Have a nice evening.
Yes, thank you. So yeah, this portion, it's more on anything you can ask to us. We will be waiting here at least next 10 minutes, 15 minutes. So you can come up, you can ask us any kind of question. So yes.
Yes, I have a question. This seems to be an organization for young people. I'm not so young, so.
So basically, our organizations is follows on the 18 to 35 years, but we have positions for people like experts like you, and also professors, industry experts, so to advise our projects, so become an advisor for these particular groups. So that is the portion. It is open for who are more than that age. So if you would like to advise any of our group, we will be really happy to talk about more about it. So yes, that's the situation inside the group.
If also, I guess in general, you're more than welcome to contribute however way you want, regardless of age, of course. The only restriction is that any formal position, such as the co-lead position and things like that, we have to abide by SGAC laws, bylaws, which then if you're outside the age range of 18 to 35, you wouldn't be eligible. But there's nothing that would stop one from participating, and I don't think we will be imposing any age restriction on just participation.
Yeah. Okay, thank you. That was my question.
Yeah, also thank you so much for joining to us for today. Okay.
Yeah, you guys are pretty quiet. Maybe we can stop the recording now.